So we are going to be learning to apply linear functions. So we're going to be doing some data practice with two problems today that are similar to what you're going to be doing in class. So the first one is show that triangles A, B, and C, where A is 3, 4, B is -2 and 7, and C is 6, -1 is an isosceles. So one of the things we need to first know is what is an isosceles triangle? Well, an isosceles triangle is simple. Its two sides are identical. So on this screen that I've drawn, I can clearly see that it will be B to A and A to C are the two lengths that we need to be looking at. So those are two I'm going to focus on. So if I'm looking for the length of AB, I've just rewritten my two coordinates with x1 and y1, x2, y2. We need to think about what is the rule for a length of line segment, which is Pythagoras theorem. And in 4a, we are going to say our x, so x2 minus x1. And for our b, we're going to have our rise, which is y2 minus y1. So all we're going to do is substitute our values that we have. So now we've got -2, take away 3, plus in brackets squared, plus y2, 7, take away y1 of 4, squared equals c squared. So if we simplify this, -2 take away 3 is -5, -5 squared is 25, and 7 take away 4 is 3, 3 squared is 9. If I add those together, I get 34 is equal to c squared. If I square root, I've got c is equal to square root of 34, and I can't simplify that, so I'll leave it in that form. If I do the same for AC, again, I'm just going to list my two coordinates and write down the formula of Pythagoras theorem. So I'm just going to substitute my x values in. So it'll be 6 take away 3, and my y values, -1 take away 4. Again, if we simplify this, 6 take away 3 is 3, 3 squared is 9, -1 take away 4 is -5, -5 squared is 25. We add those together, so 25 plus 9 equals 34, and we've got 34 is equal to c squared. If I square root, I'm going to end up with a square root of 34. So this shows me that both AB and AC are square root 34. So therefore, two sides of the triangle ABC are equal. So the triangle ABC is an isosceles. Okay, so let's look at the second question. Now, this has got three parts. So what you'll notice with this question is I've put in bold. So I'm going to be doing find the equations of the perpendicular bisectors of AB and BC on this slide. So this problem is we've been given a diagram that shows a circumcircle of the triangle A, B, and C, where A, B, and C are points around the circle. The first thing it's saying is find the equation of the perpendicular bisectors of AB and BC. So the first thing we need to do here is we need to look at one, understanding what a bisector is, and that says goes through the midpoint of a line segment. So we've got this here, we're looking at the midpoint here, and is perpendicular to that line segment. So that means we also need to understand what perpendicular means. So let's start up with AB first, and then we're going to move on to BC. So the first thing we need to work out is gradient of AB. So to find out the gradient, we need to use our gradient formula, y2 minus y1 over x2 minus x1. The second is I've just labeled this as x2 and x1, y1, x2, and y2. So if I put those into the formula, I'm going to be given 5 take away -3 over 2 take away -1. We know a negative and negative are a positive there, so which means it's going to be 8 over 3. The next part is we're talking about perpendicular gradient. So because we know it's going to be perpendicular, we need to use the rule flip, and if one's positive, we change the sign. So we've got 8 over 3, so it's going to turn into 3 over 8, and we put a negative sign because one's positive, one's negative. So now we've got the gradient of the perpendicular. To find the bisector, we need to cut it in half and find the midpoint of A and B. So this means we are going to use the midpoint formula. And again, I'm going to use my points up here that I've already labeled. So I've got x1 is -1, x2 is 2. So I've got -1 plus 2 over 2 and 5 plus -3 over 2. If I simplify that, that will give me half and 1. So x is half, y is 1. That is my midpoint. If I'm going to find an equation now, of the perpendicular bisect, I'm going to be using this coordinate here, and I'm going to be using my perpendicular gradient. So that means I'm doing point intercept form, equation of the perpendicular line, and I'm using a formula m in brackets x minus x1 equals y take away y1. So I'm just going to substitute my values in. I've got -3 over 8 will be m. I put half as x1 and I put 1 as y1. Now I just need to simplify this. So the first thing I'll be doing is expanding -3 over 8x, and -3 over 8 times -half. That would be 3 over 16. Now I'm just going to get 1 to the other side. So that means I'm saying 3 over 16 plus 1. Well, 1 is the same as 16 over 16, which will be 19 over 16. Now I've done the first one, line, AB. I'm going to look at the second line, which is BC. So to start off, again, I'm going to look at the gradient of BC. So I'm going to first look at the gradient formula and label everything x1, y1, and x2, y2. If I'm going to plug everything here, it will end up being gradient is equal to -1 take away 5 over 4 take away 2. If we simplify that, -1 take away 5 is -6, 4 take away 2 is 2, -6 over 2 is -3. Finally, I've got my perpendicular gradient of BC. M is equal to 1/3, because we know we are flipping, so 3 over 1 is the same as 1 over 3, and we put a negatives in the first one, so it will be positive for the perpendicular. The final part is we need to find the midpoint, because that's what a perpendicular bisect. A bisector is a line that crosses in the middle. So we need to look at the midpoint of BC. So that means I'm adding x values up, and dividing it by 2, and adding the y values up and dividing it by 2, which will give me 3 over 2. The final step is I've got my perpendicular gradient, I've got my point, so I'm going to create an equation using point intercept form. So that means I've got m in brackets x minus x1 is equal to y minus y1. I substitute my gradient in, and I substitute my x and my y into the formula. The next part is I need to expand. So I've got 1/3 x, and 1/3 times -3 is -1. And then I grab the -2 from the y to the other side, and it will be y is equal to 1/3 x plus. So let's go to the next part. So now we've got the two equations. We can look at the part B. The circle has its center D at their intersection. Find the center of the circle. So if they have the center at the intersection of both these lines, then that means we can use either substitution or elimination. I'm going to pick substitution because they're already both equal to y, which means I can make them equal to each other. The first step that I will do is I'll get x to one side, so I'm going to add 3 over 8x to both sides, and then that's going to rewrite it. Now this is where, because of we've got 1 as 3, 1 as 8, we need to get them to be the same size. So I'm going to make them to be out of 24 because that's the lowest common multiple. So now I've got them to be both out of 24. The next step is we can add them together. So 8 plus 9 equals 17. So I've got 17 over 24x plus 1 is equal to 19 over 16. The next step is I'm going to take 1 away. So that means I'm really taking 16 pieces away out of 16. So 19 take away 16 is 3. So that gives me 17 over 24x is equal to 3 over 16. Now I can also rewrite it by putting my x on top of my numerator. So that gives me 17x over 24 is equal to 3 over 16. Now the next step is I want to get rid of my fraction. So I'm going to times both sides by 24, and that will cancel this out. And I'll times both sides by 16, and I'll cancel this out. So I've just rewritten it as this. 17 times 16 is 272, and 3 times 24 is 72. So it gives me 272x is equal to 72. To get x by itself, I divide by 272, and I can simplify this by putting it into the calculator, and it gave me 9 out of 34. I can substitute this value into my equation to find the y value. So straight away here, I'm just got this, and I'm grabbing 9 over 34, plugging it into the equation. 1 times 9 is 9, 3 times 34 is 102. We know plus 1 will be the same as 102 over 102, so it's really saying 102 pieces plus 9, which is 111 pieces out of 102. I can simplify that to 37 over 34. And using those x and y coordinates, I've got my d value, which is my intersection. Now, C, to confirm D is the intercept. So at the moment, we know that we've got a D value that's here. So to know that D is the center, we need to look at the length from D to B, to C, and to A. Because each of those in the center should be the radius. So if they are the same, then it means that it is the center of the circle. So first, let's look at length of DA. To find out the length of DA, I'm going to use Pythagoras theorem, which means I've got A and I've got my D value. I plug them into the Pythagoras theorem, so x2 minus x1 squared plus y2 minus y1 squared is equal to c squared. I simplify it down to get c squared, so I've got it's 21,170 over 1,156 is equal to c squared. And finally, I square root it and I get 4.279. If I do the same for dB, I grab my B point, I grab my D point, I plug them straight into Pythagoras theorem. I simplify, and I've got the same 4.279. If I do the same for DC, I grab my points C and D, I plug them into the Pythagoras theorem, and if I simplify, I end up having 4.279. So therefore, I can say that DA, DB, and DC are equal. Therefore, D is the center of the circle.